Hi everyone, good morning. Assalamualaikum, selamat sejahtera. Say hi those online dengan saya. Siapa yang online dengan saya boleh say hi. Okay, let's start our lesson today. So we just go through some important point for topic gravitation for chapter 3. Okay, the first part you discuss about Newton's law of gravitation. We just go to rekas dulu gravitation. Sebelum kita jawab soalan Okay, the formula F equals to G mm divided by R squared. So based on this Newton's law of gravitation states that gravitational force between two objects directly proportional to product of masses of the two objects and inversely proportional to the square of distance from centers of the two objects. Okay, we have two objects like this, center to center measured as R. Okay, so there is gravitational force between two objects. Okay, number 2, we discuss about centripetal force. Okay, object that orbiting, for example, a satellite orbiting the Earth. Okay, it has certain speed that we call it a linear speed or orbital speed that keep changing direction. So there is a centripetal acceleration. So the force that causes the object to maintain in the orbit, we call it centripetal force. F equals to mv squared over r. Okay, compare with F equals to ma. So you will get A here is equals to b squared over r. Then we have centripetal acceleration. A equals b squared over r. Okay, as we know that between satellite and the Earth also there is gravitational force. Thus, centripetal force equals to gravitational force. Okay, so we have G mm divided by r squared. So just cancel this one and cancel one r. So you will get from here v squared equals to gm divided by r. So you have v equals to square root of gm divided by r, where v is known as linear speed. Okay, okay, so this one I just play with the formula. At the same time, I just mention what important points in this topic. Okay, so you have this one is the linear speed or orbital speed. Okay. Okay, so if you have another one, like let's say the orbital period for one complete revolution, the satellite orbiting one complete revolution. So you have time taken for the object to orbit in one complete revolution is t, which is we call it period. And distance travel, one complete orbit means one complete circumference of the circle, which is distance that we call it 2 pi r. Okay, so from here also you can get another one formula for orbital speed ataupun linear speed, which is equals to distance travel 2 pi r, the time taken is period. Okay, so you have two formula for linear speed. You can use this one or you can use this one. Depends on what information you have. Okay. R is orbital radius. Okay. And then we discuss about gravitational acceleration. Weight also equals to gravitational force. Right? You just cancel here, so you get G equals to Gm over. Okay, so Gm, the product of universal constant and mass of Earth are constant. So this one ni satu constant tetap. So we can see from here G is inversely proportional to R squared. The value of G depends on R. We have this formula, G against R. Here, radius of the Earth to R. Okay, from 0 to radius of the Earth. This is Earth, this is radius of the Earth, mean at here is 0. So at center of gravity, gravitational acceleration equals to 0 dekat center sini. Okay, so from O to R. Okay, from O to R, go to the surface from center of gravity, gravitational acceleration increases. So you can see the relationship here is directly proportional. And then when reached at the surface of the Earth, the value of G equals to Gm over. If you calculate here, G multiply mass of Earth divided by radius of the Earth squared, you will get 9.81 meters second. So the value is 9.81 meters second. Okay, after that, as the object at the surface, the value of G is 9.81. So this is the maximum value for gravitational acceleration of the Earth. So as the object go further, okay, pergi lebih jauh, okay. So I just draw it like this. Go further. Okay, so you can see the graph is like this, showing that G inversely proportional to R squared. So the value of G decreases when R increases by this formula. Okay, so that's why we get this formula, this graph, showing the relationship between G and R. This one is small r. Okay, so you have the formula for to calculate gravitational acceleration. G equals to gm divided by r squared. Okay, and then after that, when object or satellite, man-made satellite, launch to reach a certain orbit and orbiting, okay, the value of required speed for the satellite to be launched and able to reach the orbit, then orbiting there. So we call it escape velocity. Okay, so let's say satellite made here and certain speed. When reach this minimum value of speed, the satellite will able to overcome the gravitational force of Earth and then escape to outer space. Okay, escape. So bila dia escape, dia boleh stay at the orbit, orbiting a certain orbit around the Earth without fall back to the ground. If the satellite not able to overcome the gravity, it might fall back to the ground. So we need to reach this minimum value of speed in order satellite to escape from gravitational force of Earth and then able to reach certain orbit and orbiting there. Okay, we call it escape velocity. Escape velocity is based on the principle of conservation of energy, where kinetic energy of the satellite equals to potential energy. This is this here. Okay, so you have V squared equals to 2gm divided by R. So from here, escape velocity is square root of 2gm divided by R. Okay, so this is a formula for escape velocity. So escape velocity depends on mass and also distance R. Okay, if we want to calculate for escape velocity of Earth, meaning 2gm, 2gm of Earth divided by radius of Earth. If you want to escape velocity of Pluto planet, 2gm mass of Pluto divided by radius of Pluto, just like that. Okay. So itu adalah overall, and then kalau ada lagi satu formula yang mass of sun tu actually the same formula je. You boleh guna balik yang centripetal force. Ini yang kelima. Kalau you nak cari mass of sun, so you guna formula tadi, mv squared over r, gmm over r squared. Okay, so small m you can cancel, and then you substitute v. V dengan 2 pi r over t. Okay, so you dapat ni 2 pi r over t squared R1 cancel. So equals to GM. Okay, so you have 4 pi squared R squared over T equals to GM over R. Okay, so just combine. So you have M equals 4 pi squared R cubed divided by G. Okay, so you want to calculate for mass of sun, means radius of orbit where sun is the focus, and then G times period of orbiting of the object. Let's say sun is the focus and there's earth orbiting the sun. Earth, sun. Okay, so this is the value of R. Okay, and then period T is for earth orbiting the sun. So you will get mass of sun. Okay, when you formula. Okay. Okay, and then number 6 is the Kepler's law. Okay, the first law states that okay, the shape of the orbit always ellipse, ellipse, ellipse shapes of orbit. Okay, okay, where sun is the one of the focus. Okay, and then this one we have two Kepler second. Kepler second states that sun is the focus. Okay, let's say there are planet orbiting A to B, C, D. Okay, okay. For same time taken, let's say 1 month. Okay, the planet will sweep out equal area in equal time, meaning area covered by AB is equals to area covered by CD. Okay, so means the object sweep out equal area in equal time. Okay, kalau ini 1 month, so area sini same size. Okay, ini should be the smaller lah. Ini should be smaller. Okay, kena di sini. Speed here is higher. Speed here is smaller. Closer to sun, speed is higher. And then Kepler's third law. Sorry, I think I miss out T squared here. Miss out T squared here. Okay. So for Kepler's third law, I go back to this one, this formula. Mass of sun tadi. And balik tadi ialah 4 pi squared R cubed by T squared. Now I just change, make it T squared as a formula, as the title. So I have 4 pi R squared R cubed GM. So you see, 4 pi squared over GM is a constant. Thus, we get T squared directly proportional to R cubed. So this one is Kepler's third law. Okay, the square of period is directly proportional to the cube of radius of orbit. Okay, so kita dah cover semua formula. So this chapter memang banyak formula. So you must get used to it. Kena tahu guna. You must know how to use the formula. Okay, so saya dah discuss all the formula secara ringkas. Okay, now we go to the question. If you have any question, then you can write in chat. Kalau ada soalan, boleh tanya di chat. Okay, now we discuss the question. Okay, gravitation, paper 1. Okay, number 1, which of the following statement explain Newton's universal law of gravitation? So if you forgot the formula, try to go back to the list of formula. Some of the formula is given in the list. Okay, because to answer this question, you must know the relationship. Okay, F equals Gm. Okay, the first one. Gravitational force inversely proportional to the square of distance between two bodies. Yeah, correct. Number 2, part 2. The gravitational force can be attractive force or repulsive force. Is it correct? No. Gravitational force is attractive force, not repulsive force. 3. Gravitational force directly proportional to the product of masses. Product maksudnya multiplication of the two bodies. F directly proportional to product of masses of two objects. Yes, this is correct. Ini ialah multiply, bukan salah. Ini multiply. Okay, so kita dapat answer only 1 and 3. Correct. Okay. Number 2, graph shows relationship between gravitational force and mass for object near to Earth's surface. Okay. Gradient of the graph represent apa? Okay. Which one is the answer? It should be. Okay, we look again. This one. This is gravitational force. This is mass. So we use the formula F equals to mg. Object close the Earth, gravitational force act on the object. So you have G equals F divided by M. Okay, if you calculate using gradient, this is G, this is M, means gradient equals, that's equals to F. Here, the gradient equals to gravitational acceleration. Okay, so answer should be A. Okay, acceleration due to gravitational force. Okay, number 3. Earth is pulling the moon with gravitational force 10 to the power 20. How much gravitational force of the moon pulling Earth? As we know that two objects experience gravitational force and we call it attractive force. F, Earth, F, let's say Earth and Moon. Okay, so the magnitude same, is divided by r squared. Okay, so the value should be the same. Okay, number 4, calculate gravitational force between two planets. Each planet has mass of, and the distance between each planet, okay, distance between the two planets, okay, is 2.3 times 10 power 11. Okay, so you have here G given, universal gravitation constant. So what formula that we should use? Okay, F Gm So you just substitute 6.67, 10 power -11, mass 1.23, 10 power 26, 5.21 times 10 power 22. Divide by 2.30, 10 power 11 squared. So it's quite agak banyak you need to calculate. So you just calculate for this one. Okay. Number 4, you should get the answer 8.80 and 15 Newton. C. Okay. Be careful calculation because involving large number. Number 5, a satellite placed in a fixed orbit and orbiting the Earth. The satellite remain in its orbit and not escape into space because of the satellite. I think ada lagi tu. Okay. It should be like this. Sambung. Sambung sentence. Okay, the satellite remained in its orbit and did not escape into space because of the satellite. Okay. Number 5. Experiencing 0 weight. No, it does not escape yet, right? Moving in vacuum, no. Moving in high speed, also no. Okay. Okay, always pulled by gravitational force of the Earth. That's why it cannot escape. Or we can say the escape velocity is not enough. It does not reach escape velocity yet. So it means it's still pulled by gravitational force of the Earth, right? Number 6. Diagram below shows a planet of mass m move in a circular orbit of radius r around Sun of mass m. The planet takes orbital period t to complete one revolution, one complete orbit. Okay. Which of the following shows correct relationship between t, m, and r? Okay, so you have this relationship. 4 pi squared r cubed divided by gm. Correct? So from here you can see t directly proportional to m squared. No. T directly proportional to mm. No. T directly proportional to r cubed. No. T directly proportional to r cubed. So you can see t squared directly proportional to r cubed. Kepler's third law. This one d dan q. Okay, so based on this formula lah. Okay. Yeah. Jadi formula ni sangat berguna. You boleh guna untuk Kepler's law or to calculate mass of sun. Okay, or mass of earth. Boleh guna. Okay, now we go to 7. Number 7. Figure shows a research satellite needs to orbit at height of 380 kilometer to capture clear image of the surface of the earth. Okay, given radius of the orbit of moon. Okay, orbital period of moon. Calculate orbital period of satellite. Okay, what formula that we should use? As you can see from here, given is only the R and T. So if R and T, then we can use Kepler's third law. Kepler's third law. Square of period directly proportional to cube of radius of orbit. So if this one is directly proportional, if you have two situations like this, okay, satellite, okay, orbiting the Earth, at the same time there's another one, moon orbiting the Earth. So we have two situations. This we can have T1 squared over T2 squared equals to R1 cube divided by R2 cube. Okay, so you have this one. The T1 and R1 you can label it for satellite, T2 and R2 for moon. Okay, so in this question you need to find orbital period of satellite. Let's say I want to find T1. Okay, so try to use this formula. T1 is for satellite, so I just put TS. Okay, T of moon given in hours 655.2. So T of moon squared equals to R satellite squared, cube, divide by R moon cube. Okay, so TS squared over, okay, just now it's moon 655.2 squared equals to satellite. Okay, satellite orbital period. Sorry. Radius for the satellite, radius for satellite we need to find first, because equals to height given means radius of the Earth plus height. So is radius of the Earth is, okay, we can get from other question because not given here. Radius of the Earth, where is it? Let me look at here. If I can get somewhere from here, should refer to the list of formula. If I'm not mistaken, because I'm not having it here, so 6.37 times 10 power 6 meter. Okay. Plus 380 10 power 3, because here it's kilometer. So you have 6.37 10 power 6 plus 3 plus. So I have 6.75 10 power 6 meter. Okay, so I will use that formula. Divide by, for moon, 3.83 10 power 8. Okay, so you solve this one to find period of satellite. Okay, so you will get the answer in hours also, because here is hours, so you get your answer in hours. Okay, so for this question you should get the answer B. Okay, so 1.53 hours. Okay, do you have any question? Ada soalan? Okay, number 8. A stone tied to the end of a rope and rotated to form a circle as a figure. When rotation of stone reaches O, the stone is released from which direction the stone will continue to move. As we know that if the stone or orbiting in the orbit like this or circle, its direction of velocity is tangent to the circle. It always tangent to the circle. Okay, so when the stone is released, due to effect of inertia, it will continue to move in the same direction, which is tangent to the circle. So it should follow direction of Q. Okay, Q, which is tangent. So ini ya, Q. So answer is B. Okay, number 9. Which of following statement is not true about geostationary satellite? So you must know the properties of geostationary satellite. Period T equals to period of the Earth, which is 24 hours. Same location. Okay. Same direction of orbiting. Okay. So always at the geostationary satellite orbit. Okay, which one is not true? Okay, it's orbit the Earth in the direction of Earth rotation. This one is true. The period of its orbit equal to period of Earth. True. Its orbit is centered on equator. True. D rotates on the axis period equals to that of Earth rotation. It does not rotate at its axis. Dia tak ada macam tu. That's why ini wrong. Only Earth that rotate its axis. Okay. Satellite dia tak ada rotate axis dia. Hanya Earth saja yang rotate. Okay. So ini jawapan not true. Okay, number 10. A satellite always on the surface of Earth in the same place through a year. What is length of time for satellite to move in its orbit? Number 10. Okay, a year. Length of time for a satellite to move in its orbit. Because same as Earth, 365 days. Okay, now we go to paper 2, section A. Diagram 2 shows satellite of global positioning system that has been launched from Earth to outer space. Before leaving the Earth, a satellite must reach escape velocity to allow it to be in outer space. Okay, given mass of Earth and radius of Earth. Determine the meaning of escape velocity. Okay. The minimum velocity. Escape to overcome gravitational force and escape to outer space. Okay, the minimum velocity needed for the satellite to overcome gravitational force and escape to outer space. Okay, itu maksud escape velocity. Okay, so you need to memorize ini definition. Calculate escape velocity of the satellite. So you must know the formula, escape velocity. Check the list of formula, 2g divided by r. Okay, so you just substitute 2 times the value of g, then power 11. Value of g should be given in the list. 6.67 times 1011, sorry. Mass of Earth 5.97 times 1024. Divide by R. Okay, so you calculate for this one. Be careful when you calculate. You get 1.12 10 meter second negative 1. Okay, or you want to write in kilometer per second is 11.2 kilometer second negative 1. Okay, so substitution correct, answer with unit correct, 2 markah. Okay, part C. The satellite has reached outer space and is orbiting the Earth at altitude h. Altitude maksudnya height. Calculate linear speed when orbiting the Earth. Okay, linear speed formula is square root gm divided by r. Okay, sama juga, you substitute semua. 6.11 10 power negative 1. 6.67 g multiply m. Divide by, okay, height given in meter like this. Okay, so means 6.37 10 power 6 plus 2.02 to add. We need to add because given is height. Height ni ketinggian atau height. Okay. Okay. So you will get the answer. Okay, meter second negative 1. Okay, so this one is the linear speed or orbital speed. Formula just a bit different from escape velocity, so don't get confused. Okay, number 3. Diagram 3 shows centripetal force speed and are used as an activity in the lab. rubber stopper. So ini you nampak dia punya B dia. So gravitational force, and there is a centripetal force. Name the force causing the rubber stopper to move in circular path. We call it centripetal force. Kalau objek tu move in circular motion, maksudnya ada centripetal force. Draw direction of the force. Okay, draw kat sini. So I just draw just now. So boleh tanda macam ni. Arrow. Okay, tanda arrow saja. Okay, bahagian B, if the mass for rubber stopper 30 gram, radius R 1.2, speed of rubber stopper 8. Calculate value of force. Just use the formula. mv squared over R. 30 gram, you convert to kilogram. V8 squared. R 1.2 meter. Okay. Calculate for this one. You will get 1.6 meter. Mass mesti tukar kilogram, and mesti kilogram. Sebab unit Newton, SI unit. Substitution correct. Final answer plus unit. Okay, part 2. What will happen to value of force if rubber stopper is swung with faster speed? Still using the same formula. mv squared over it means in force. So you can see that centripetal force increases. Okay, very simple, right? Part C, the speed of rubber stopper increase until string that connects the rubber stopper breaks. What is subsequent motion of the rubber stopper? Just now it moved with that keep changing direction which is tangent to the circle. So when it breaks, means it will continue in the same direction due to effects of inertia. So it will travel along the tangent to the circle. Okay. Move in the direction to the circle. Okay. Or in the direction of linear speed. Okay, ini pun direction, linear speed, tangent to circle. Okay, number 7, diagram shows athlete in hammer throw is rotating the hammer in a circle before releasing it. The linear speed of hammer is 20. Name the type of force that acting towards the circle. Ini pun sama, question sebab dia moving in circle, there is centripetal force. State direction of the hammer after releasing it. Okay, direction is tangent to the circle. Okay, tangent. Okay, next, part C. As an athlete who wants to win the event, some of techniques should be done. So below shows some technique. P, linear speed of hammer. Okay, time. Rotational. Okay, angle of projection. Okay, based on table 7, state the suitable technique. Give one reason for your suitability of each technique. Okay, time taken for rotation of the hammer. Okay, so means they should rotate for longer time. Okay. So why longer time? Because to increase the final velocity. Reading 8 means the final velocity achieved is higher. So it will travel further. Okay, to increase momentum. Okay, momentum. Okay, linear speed of the hammer should be high linear speed. Okay, what is your reason? First, high momentum. Okay, angle of projection of the hammer. So angle should be -45. So means increase distance or horizontal distance. Increase horizontal distance travel. Okay, now we look at again which one that we should choose. Linear speed should be high, time taken should be long, angle should be 45. It's R. So here answer is R. Determine the most suitable technique is R. Okay, section B. Diagram 10.1 shows a planet evolve the sun. The time taken for planet to travel from A to B is equal from C to D. Remember what is this law? It's Kepler's the second law. Okay, now we look at state the shape of orbit. You can see the shape is ellipse shape. For section B, you need to write the answer in the space given, not here. So I just write here so that you can refer to the question at the same time. Ellipse shape. Okay, bagian B, compare arc length of AB and CD. Okay, you can see arc length of AB is longer than CD. Okay. Compare area covered by planet region FAB and FCD. Area of FAB equal to FCD. Compare linear speed of AB and CD. Linear speed of AB is higher. Because AB you can see clear, close to the sun. Close to the sun, the speed is higher. Okay, now we go to the next one. This one you get 3 marks. Okay, we go to the next one. State relationship between time taken and area covered at both regions. Okay, so if this one, okay, area same, linear speed is higher, area is same. So what we can say about this one? The time taken same. As the area of both regions. Okay, same time taken, so area are same. Okay, the difference is the, so we can see from here, this is the long cap plus okay, means the planet sweeps out equal area in equal time. Area same, time taken same. Okay. But D, the Earth has high escape velocity. Explain briefly one benefit and one implication of high escape velocity on humans. 4 marks. Okay. What is the advantage? Earth maintain the because the oxygen or the air molecule not able to escape easily due to high escape velocity. Molecules of air does not easily escape to outer space. Okay. Another advantage is aircraft can travel at higher altitude. Okay, maksudnya dia tak boleh escape easily walaupun berada di high altitude. So here is only 4 marks. Okay, one implication. Okay, so more fuel is required for launching of rocket. To achieve the minimum velocity required or escape velocity, so the gas that released out for the launching of rocket must be at the very high speed. Okay, so it requires more fuel to launch the rocket. If not, the rocket cannot escape to outer space. So this is the implication. Okay, okay, let's look at the last question. Ada tak last lagi? Okay, ada soalan yang tak ada di sini. Okay, so for topic here, I think that's all. Untuk topik gravitation, okay, so if no question, then I will end live now. Okay, thank you for joining me. Bye. Oh yes, Ompa, oh, is this Ompa Lumpa? Yes, you have question. What is your question? Okay, you can write in chat. Exam, can we say law of areas instead of Kepler's second law? I think it's better you write what is mentioned in the textbook, which is Kepler's second law. Actually, the same law, right? But we use the name one, Kepler's second law. Okay. Macam Newton second law. Okay. Newton first law. Newton first law also known as law of inertia, but we always state as Newton first law. Okay. 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 Thank you for joining me now, today. Bye. Good luck for those who will sit for exam. Bye.